And now we can start. The nice pretty red light, huh? Okay, linked list. So what is a linked list? It says it's an abstraction of a list. But what does that mean, an abstraction of a list? It's like a list. It's a sequence of nodes. A chain of nodes. Now for you, when I say node, you can think from 203, CPCS 203, you can think objects. It is a chain or a sequence of objects where every object points to, connects to the object that comes after it. So it's very similar to an array. An array, if you have an array of 100 objects, you can have an array of object references, right? If you have an array of 100 objects, each object comes after the next. This is very similar. This is a chain, مثلا 100 objects. Each object points to the next one. So now we say, why not just use an array? Because each node inside an array is stored physically in contiguous memory. And we spent about 20 minutes last time talking about the benefits, the fa'idah of contiguous memory. What does contiguous memory allow us to do for an array? 2 words. Yes? Access easy, but the 2 words I'm looking for, that's correct. 2 words I'm looking for, direct access. Remember, we can calculate immediately any cell of the array. How? Because we know the beginning address of the array, and then we can calculate how many bytes down, which index 10, so 10 times the number of bytes, and we can calculate immediately, it's called direct access, the location of any cell in the array. This is the benefit of contiguous memory. We mentioned in detail last time. What is the negative of contiguous memory? Because of the benefit, there's also a negative. The negative is, if we say, yeah, Java, I want an array of size 1 gigabyte. It's a big array. Java will look to your memory, and if you do not have 1 gigabyte contiguous, Java will say, sorry, I can't do that. Now maybe you have 1 gigabyte, but you have 300 megabyte here, 400 megabyte here, 200 here, and 200 here. It's in different places of your memory. It's not contiguous. Who's with me? Okay? So you might have the memory available, but not contiguous. So the contiguous has a benefit for direct access, but the negative is as we just described. Arrays, also the negative is they're not fixed size. We mentioned the other negative is that, so they cannot grow, they cannot shrink, that you have to, when you insert or delete from the beginning, you will have this shifting. You have an array of 1 million elements, you want to delete index 0, you have to shift 999,999 elements. This is horrible. Very slow. Okay? So why use linked list? Because they are dynamic. They can grow as needed. They can shrink as needed. The memory usage is beautiful. It does not use contiguous memory. Rather, every cell has, every node, every object has its own memory, and that object will point to the next object. So object number 1 is in memory, and object number 1, will point to object number 2. Object number 2 will point to object number 3, and so on and so forth. Object 3 will point to object 4. But it's not necessarily in the same locations in memory. If this is object 1, this is object 2, 3, 4. 1, 2, 3, 4. Object 1 will point to 2, 2 to 3, 3 to 4. Now this looks like it's contiguous, right? But it's possible, not just possible, probable, that here's object 1. Object 1 will point back here to object 2. Object 2 can point over here to object 3. Object 3 can point here to object 4. Maybe object 5 is back there. Each node has its own space in memory. Maybe one node is over here in memory, and the next node is up there, and over the next one over there, the next one back this way. So how do we know where the next node is? How do we know where node number 2 is? It's stored in the, I don't want to say next. Node number 1 knows where node number 2 is. Node number 1 knows where is node number 2. This is the basic idea. Then insertion and deletion is very easy. No shifting. So I always need an example. So we're going to use name. Khalid. Khalid Baha. Khalid Baha Khalid. Let's get another. Khalid Baha. That's long. Abdurrahim. Khalid Baha Abdurrahim and so Khalid Baha Abdurrahim Ghassan. So how about we just Khalid Baha Ghassan. Can you point to each other? Khalid, point to Baha. Baha, can you point to Ghassan? No, to Ghassan. Ghassan. Okay? Ghassan, you point to the ceiling. We're going to do this for like, no, come on, just for 1 minute. Ta'ban, mashallah. Can you help him maybe hold his arm? Okay. Okay. Can you point? This is our list. Abdurrahim is not here yet. So, right now, this is the first node. Khalid. Baha is the second node. Ghassan is the third node. Who knows where is Baha? Only Khalid. Who knows where is Ghassan? Only Baha. Only Baha knows where is Ghassan. Now, let's say that we want to insert, we assume, naftarid, we want to insert Abdurrahim between Baha and Ghassan. All we do is we're going to make Abdurrahim point to Ghassan. Go ahead, point. How? We do this next time. Okay? We make Abdurrahim point to Ghassan, and now we make Baha point to Abdurrahim. Bas. 2 changes. Who's with me? Did we do 1,000 shifting, million shifting? 2 changes. Much faster. Okay? Just 2 small changes. And we will come back to this example. So insertion and deletion is very cheap, very easy. Is there a negative aspect? There's always positive and negative. Okay? The negative aspect is that getting to a node is not easy. If you want to get to node number 12 of an array, do you have to do a for loop to get there? No, you just access index 12. But here, if we want to get to Ghassan, can we access Ghassan mubashiran? No. We have to say, are you Ghassan? Who's next? Are you Ghassan? Who's next? Are you Ghassan? We found Ghassan. This is how it works on a linked list. So traversing, we talked about the word traversing, very important. We use it today. Walking down the list, traversing the list is quick. Well, it's not needed for an array to find it's not needed of an array to locate a specific index. But on a linked list, you have to traverse down. If you want to get to the 10th item, you must walk down your list. So in detail, a linked list is a collection of data. Okay, each element has the location of the next element. So every node basically has 2 parts. We have the data part of the node, and then we have probably the most important part, next. Next has the unwan of the next node in memory. So the data part, and the data part can be tawil. It can be maybe a first name, a last name, an ID, an address, a this, a that, a lot of data. That's the first part, all of this data. And the second part is the link, the connection. It stores the address of the next node in memory. Okay? So here is a class for a linked list node. So here is a class. We know that a class from 203 is like a mukhattat, right? And from the mukhattat, we make nodes. So this is just the class, like the skeleton, whatever you want to call it, the blueprint. From this blueprint, we will make nodes. So we call the class LL node for linked list node. We have 2 data members, an integer, the name is data, And then we have another mutaghayyir next. What is this? Is it a double integer? It's a marja', right? It's a reference, right? It's a reference to an LO node. Which one? The next one. Okay? So here it's a class LO node, and one of the data members is of type LO node because it will store, this data member, ismuhu next, will store a reference to the next node. And we have some constructors. This should look similar to what you have seen in 203, but we will show you as a reminder to wake some of us up. So first we look at this one. When do we call the constructor? Whenever we make a new object, we call the constructor, right? So imagine inside our main, we want to make a new LL node with two parameters. The first parameter is an integer. Second parameter is, it's not an object, it's a reference to an object. Okay? So we with two parameters, an integer and a reference to an LL node object. What do? We take I, the integer, and we save it into data. And then we take in the reference and we save it into next. Who's with me? Okay? The second, that was the first constructor. This one's wadih. It's obvious. The first one, I want to make sure we all remember. What if from main, I make a new object of LO node with one parameter, just the integer? What does this do right here? This will call the second constructor. This is the istid'a for constructor thani with two parameters. I is the same I, and the second parameter is null. So the reference here will be null. So we call the second constructor, I comes to here, null will come to here, and now we save the I into the data, and we save the null, it goes to n, so the null will be here, we save it to next. So this is our constructor to make nodes. Okay, this is the explanation. So here's three nodes. Afterwards we can make three nodes. LO node A, new LO node 1. So 1 is the data, right? This is with one parameter. We make three of them. Node B has the data 2, node C has the data 3. Here's our three nodes. How can I connect A to B? Using this line. If I say A dot next equals B, take B. What is B? Assalamualaikum. What is B? B, if you look back, B is an unwan. It's a marja'. It stores an unwan. B stores an unwan to this new node right here. B has an unwan to this new node. So what does this next line say? This says take the address that is inside B, take the unwan inside B, and save it into the next of A. So what is A dot next? A is an unwan to this whole node. So, then A dot next is this guy. A dot data is this guy. So A dot next is right here. It says take the unwan of B and save it into A dot next. Okay? So the address of B will be right here. What is the natija? Is they will now connect together. Who's with me? What about the next one? How do we connect B and C, nodes B and C? We take the address of C, the whole address of C, which is stored right here, and we save it into B dot next. And so now they connect together. So now we can print. What happens if I print A dot data? What gets printed? A dot data will print the number 1. What if I print A dot next dot data? This says A dot next, which brings me to this node dot data, the 2. We print the 2. What about A dot next dot data? A brings me to this node. Dot next brings me to this node. Dot next brings me to this node. dot data, the 3. Who follows? B dot next dot data, also 3. And finally, C dot next dot data. Error, because C dot next, which is nothing here, it's null. And so now when I say dot data, Java doesn't say mafi data. Are you with me? It will actually give you an error. Okay, because you're trying to print a data doesn't exist. So you will get an error. Okay? So we can think of each node as an object. I say here as a record, where the most important part is really the address of the next node. So what we've said is, who knows where is Ghassan? Baha. Who knows where is Baha? Khalid. Who knows where is Khalid? This is the problem. So we have to think about that. So every node knows the node location of the next node. This is fine. So everybody knows where everybody is except the first node. So we must have inside the program a main, ra'is, whatever, mutaghayyir, that has one job, to point to Khalid. So we call this the head of the list. So how do we reach the first node? You must store a reference inside your program, and this reference variable has one job in life. I say, what is it? Hadaf wahid fi hayatihi. Can you say that? One goal in his life. His goal, point to Khalid. Is this fine? This is his only job, to point to Khalid. So we need 2 Java classes. We need the first class I just described to you, which is the LL node class. This is the class that we use to create what? To create nodes. The class I just showed you, LL node, is, I said this is the mukhattat. For what purpose? To create individual nodes. So that will just make one node, ba'dain another node, ba'dain another node. So we have a lot of nodes. Is this a list? No. We need another class that actually makes the list. So the first class is to make the nodes. We just showed you this. The second class is the class that we use to actually control our linked list. And we call it S-linked list. You can call it whatever you want. You can choose your own name. Okay, I call it S-linked list on the slides. This class has one very important variable. What is it called? Head. Or I said on the last slide, my list. It's a variable who has one goal in life, to point to Khalid. Okay? So this has one variable, head or my list, to point to our first node. We can also make a variable tail to point to the last node, but this is for later implementations we will discuss. And this class will also have many methods that we will use to operate on our list. An insertion method, deletion methods, print methods, traversal methods, many methods. All of the methods that operate on your list will be inside this linked list class. Because the linked list class is the class that actually we will control our list. Khalas, this is the list class. What is the LL node class? Just to make objects. Okay, just to make one object. Ba'dain, make another object. But the linked list class, khalas, this is your real class to make your list. So here is our class for our linked list. We have one mutaghayyir, LL node. So what is LL node? It's to be a reference variable of type LL node. I call it my list. The famous name is head, like for the head of the list. Whatever. This variable will point to Khalid. Ba'dain. Not right now. When you make a new reference variable, where does it point? Null. When you make a new reference variable, they always point to null. But its goal in life is to point to the first node of the list. So here's our constructor. So I told you this is the class for the real list, the whole list. But there's only one variable, my list. But there will be many, many, many methods. What is the constructor? When inside our main, if we say, "Ya Java, I want to make a new linked list." So Java will make a new object of this class. You only do this really one time. If you need two lists in your program for some reason, if you have two lists, you will make two objects. But if you only need one linked list, you make one object. If your linked list has 1,000 nodes, you will make 1,000 nodes from the node class. Are you with me? But from the linked list class, we make one object of linked list. When we do this, we take this variable myList, we set it equal to null. Okay? We set it equal to null, just to initialize that the list is empty. So what if I want to give you a method, an example method, to show that I told you there will be many methods here. So here's one method, as just an example. How can we show if our list is empty? Well, this is the method. What will go inside it? If I want a method, I want to write a method to show if the list is empty, return true. If it's not empty, return false. If what? If the head is null, then what? So we can say if head, that's my list, huh? You know, I prefer, that's all right. If my list equal null, that means the list is empty. You then return true. غير ذلك return false. So how do we know if the list is empty? If our head pointer is null, معنى it does not point to Khalid, it points to nothing. So we have no nodes. So the list is empty. So if I want to make a method, public boolean is empty, and I want to know is our list empty, just simply test the variable myList. If myList is null, معنى ما عندنا list, إذن return true. It's empty. غير ذلك return false. So what I want to show you now, there's also an easier way to do this. Here we have 4 lines, right? You could just do this with one line. Return myList equal null. It's the same thing. Mantiqiyan, it's the same thing. But students are comfortable with the if-else. If my list is null, return true. غير ذلك, return false. Quiz. This is fine. But I want you to be comfortable with this too. This is one line, same thing. Because my list equal null. This is true or false? صح? No, but I'm saying it's true or it's false, right? So it's the same thing, the same natija, but here it's with one line. Because you will return true if my list is null. If my list is not null, this will return false. Same thing without if and else. Who's with me? Okay? There's no if else, and it's the same thing. And so it's actually faster because we do not have the branch statement of the if else. So that's just one example. This is one example method. We will have many methods: insertion, deletion, searching, traversing. Okay? And that will be starting from next time. Next lecture, we have just insertion. The entire lecture. How do we insert Abdurrahim? You have to come next time. Because how do we insert Abdurrahim between Baha and Ghassan? This is the next lecture. Okay? The lecture after that is how do we delete Abdurrahim? We spend, mashallah, 2 lectures talking about Abdurrahim. We finally insert him. He makes sajda shukr. Then we delete him. What can we do? Okay? So the 3rd lecture will be how do we delete nodes. So those lectures will come. Today, we will not talk about insertion deletion. We want to talk about some basic concepts. So here's an example of a list. We have 3 nodes. Okay? Just make sure you have a good, pretty mental picture of what is a list. This is an empty list because my list points to null. Okay? There's an empty list. More examples. Here's a single node. Data and next, fine. We have the data part. The next is what? It is the unwan of the next node. Who's with me? The unwan of the next node. Okay, data can be tawil. Here was our class for this. Data can be very large. So here is a larger LL node class. Maybe you have a name, an ID, grade points. Most importantly, you have the last variable, the last data member, next. Okay? So if you wanted to get a visual representation of this, here's your node. You have a name, an ID, a grade points, but most importantly, you have next, which is the unwan of the next node. Okay? So how do we access nodes of a linked list? I say, what if we already have a list that has been created with several nodes? Okay, I say, don't worry about how we make this. This comes next time. But imagine we already have this list. We can access this list via our head pointer, my list. The head متغير اسمه my list. My list يشير إلى خالد. So my list will point to the first node. So right now we have my list pointing to the first node. My question is, how can we point to the second node? Can we just do this? This is a very common error, is moving my list, the mutaghayyir my list, to point to the second node. This is a problem. And it's a common error that new students will make. This is a problem. It's permissible, yajuz, in code, but it has a big problem. What is the problem? I say, think about if we make my list point to the second node. What will happen? What will happen is we will lose this first node. Okay, can all of you point? Can you point? If all of a sudden, here we have my list, so this is mine, I'm on my list, and I'm pointing to Khalid. I know where is Khalid. Now maybe I move and I choose and I point to Baha. Who's pointing to Khalid? Nobody. I'm pointing to, I said hadaf fi hayati, to point to the first node. So I'm pointing to Baha. He's the first node. Who's pointing to Khalid? Nobody. What happens in Java if nobody points to you? Java garbage collection. Khalid yabki. He will get deleted. He's crying, he gets deleted. Who's with me? It's a big problem. You cannot use this variable myList to walk down your list. You can, Jews, it's allowed, but if you do that, what will happen? You will lose those nodes. Those nodes will get deleted. Who's with me? Very important to understand this. Very important. Okay, you would lose the previous nodes. Even the important question is, how do we walk down a list? How do we traverse down our list? We need to make a temporary variable to help us do this. We make a temporary variable to help us do this. This variable is called help pointer. What is help pointer? Is it a double? Is it an integer? What is it? It's a reference variable. Help pointer is a reference variable of type LL node. Okay? So we make this new help pointer. It's right here. It's always good to initialize things to null. So fine, we can leave it. We can make it initialize to null. An explicit initialization to null. So now we want help pointer to traverse the list. Okay? So here is, I'll write it over here. This is my list. My list has a pointer going to where? It's pointing to Khalid. To Khayyad. My list is pointing to Khalid. And a help pointer. What is my job? My job is I want to traverse the list and print. This is my job. And a help pointer. I am help pointer. I want to traverse the list and print. My list, what is the job of my list? to always point to the first node, period. Never move. Okay? So we want help pointer to traverse the list. Either, if I want to traverse the list, traverse means walk down the list and print it. I want to do this, therefore I need to know what? Fit a list. Where is the list? Now, where is the first node? This is what has to happen. So we use the following line. I want to know where is Khalid. So I'm going to say, yeah, my list. Fain Khalid. So we take the unwan of my list. We take the unwan in my list. What unwan is in my list? The unwan of Khalid. We take the unwan Jew of my list and we save it into me. إذن أنا أشير إلى خالد كمان. Who's with me? Now we're both pointing to Khalid. مشهور ما شاء الله. Two people pointing to him. He's not crying now. He'll cry بعدين. So we're both pointing to Khalid. Okay? So now I'm pointing to the list. This is very important. So this line says, take whatever is inside my list and save it into help pointer. Okay? So here's our picture now. Agree? Yes. This is our picture. Okay? So before we go on, I tell you, so now if I wanted to, I could print Khalid. I could do system.out.print help pointer.data. So I can print help pointer.data and I print Khalid. I could also print my list.data. But there's no faida because when I move, my list.data will always be Khalid. But I can print help pointer.data, I can print my list.data, I can do a variety of things. The question, how do I print the second node? How do I traverse to the second node? How do I make help pointer yushiru ila notani? Okay? This is the instruction, most important instruction. This is the instruction to walk one node down the list. Help pointer equals help pointer.next. Who understands that? I don't expect you to understand that. I'm just curious. A quarter of you do. Good. So can you point, please? Yeah. And the Ghassan, nobody's watching you. I'm the only one seeing you. But the Ghassan's pointing to the ceiling. Okay, no, you're going to be tired anyway. So if you point, no, you will be because we're not using you yet. So right now, I'm a help pointer. I'm pointing to Khalid. Khalid's pointing to Baha. I come to Khalid and I print. We print your data. Ba'dain, I want to print Baha, which means I need to point to Baha. How do I point to Baha? What address is in me right? I'm a help pointer. What address is in me right now? Khalid. And I'm pointing to him, I'm printing him. Ba'dain, I want to point to Baha. Ma'ana, I need to save the unwan of Baha inside me. صح؟ مين معي؟ من يعرف عنوان بهاء؟ خالد. وبالضبط the next of Khalid. صح? Or I can say فين عنوان بهاء. So can you point a little, put your arm up? So here is Khalid. This is the next of Khalid right here. This is Baha. This is the next of Baha right here. Where is the unwan of Ghassan? In the next of Baha right here. في يد Baha. Yes? Where is the unwan of Baha? In the next of Khalid right here. مين معي? So what I'm going to say, I'm a help pointer. I'm pointing to Khalid. I want to point to Baha. كيف? I need to save the unwan of Baha into me. So, but right now, where is the unwan of Baha? Help pointer dot next. So, help pointer, like help pointer dot data. What is that? Khalid. So, help pointer. Ana ushiru ila Khalid. His whole node. So, either help pointer dot data is the string Khalid. As if you're a string. Help pointer dot next is the unwan, is the next. So I will say help pointer dot next, the unwan of Baha, save this unwan into help pointer. And now I point to Baha. Who follows me? هل خالد يبكي؟ لا. Because my list is still pointing to him. So this one line, I just gave you all of the explanation, but we're going to read it again on the slide to make sure, because I want you to be able to study this at home. So I put all of this in detail here for you on the slide. So we can skip this part. So here's our before picture. Yes? And what is the goal? We want help pointer to point to the second node. Okay? We want help pointer to point to that second node. So I just gave you the example with Khalid Baha. Now I give the example with node 1, node 2. We want help pointer to point to node number 2. The question is, how do we do that? I say, think. This second node is in memory somewhere, right? That second node, it's in memory somewhere. Is it in memory على طول after the first node? Maybe. Probably not. Probably the first node is there in memory, the second node is back there in memory. They're not after each other. It's not contiguous. Yes? It is not contiguous. The second node is somewhere in memory. It has an address. Currently, I ask you, where is that address saved? The address of this second node is saved where? Right here. It's in the next of the first node. Pay attention, Shabab. This is the most important thing. It's in the next of the first node. So we want to locate the variable that is referencing that second node. This next variable of the first node, it has the unwan of the second node. Okay? So it is storing the reference to the second node. So what we do is we save the location of the second node, which is saved right here. In this next, we need to take that and we need to save it into help pointer. Okay? So we take that reference from the next of the first node and we save it into help pointer. This will make help pointer point to the second node. Here's the instruction, and this is what happens. This goes away and it points to our second node. Who follows? This one line, help pointer equals help pointer dot next. Everybody should be able to tell me what this line does. What does it do? It traverses one step down the list. If you do it again, what does it do? One step down the list. Again, one step down the list. This one line. Every time you do it, it will traverse one step down the list. Right now, if we did help pointer equal help pointer dot next, what would happen? Help pointer dot next is the unwan of the third node. If we take this unwan of the third node and we save it into help pointer will point to the third node. So we can do this line again and again and again to walk down our list. Who follows?
Do we need loop to...
You will see. We're about to show you. Okay? So this is the idea. We could change the data value. What if I wanted to change this? I could say help pointer.data is 10. So I could change the data value. I could walk down the list, change all of the values. We can print the values, change the values, modify them. Okay? Here's our fail picture for the day. Is it funny to you? I don't know. Why is it funny? It's supposed to be funny. That too, but the arrow is pointing. I don't know if y'all do this here, but in the States, people will, because I think these days, I don't see this very common these days, but because people just have a phone, they just take the picture. But you would make a little cutoff so you can take the phone number. If you see an advertisement, they would put a little cutoff, you can just pull it, so you have the phone number and the name, right? So they spend a lot of time, mashallah, cutting everything, and then they put it inside the car. So this is why it's a failed picture. So clearly you cannot take one. Anyway, it's not the best failed picture, but it at least gives us a moment of pause. Okay. We want to traverse and print out our entire list. So the big goal for today is we want to traverse the whole list and we want to print it out. Okay? This is our goal. So we want to print, Khalid, بعدين go to بها, print بها, بعدين go to غسان, print غسان, بعدين go to the سقف and stop. Okay? This is the idea. So I say assume that we already have a list pointing, we already have my list, متغير, head pointer, pointing to an existing list. Here's our code. Okay? And I want to print all of the nodes. So here's our method, print all nodes. I want to go through this method step by step to make sure that we all understand it. Okay? So here's our method. What is the first thing that needs to happen? If I want to print the entire list, what's the first thing that always should happen? It should be automatic. Help pointer. Because if we want to print the list, ma'ana, we need to traverse the list. Can you traverse the list with my list? Answer the question properly. Can you traverse it with my list? Yes. It's bad to do so, because you lose the list بعدين. Okay? So, can we? Yes. Should you traverse with my list? No. So if you know that you want to print all of your nodes, okay, which means that you need to traverse your list, لازم, ضروري, you need help pointer. So we have help pointer equals my list. What is the fa'idah of equal my list to the sabab? Well, yeah, the fa'idah of help pointer is we don't lose my list. Why do we say help pointer equal my list? Because help pointer will ask, find a list. Yes? We want help pointer to traverse, so help pointer must know where is the first node. So this is always, in every method that you make for linked list, this is like one of the first lines. Any method for traversing, searching, LL node, help pointer equals my list. على طول. We make a help pointer يشير إلى the first node. Because we do not use my list to move. Who's with me? Are you, hands high if you're with me? Okay? You have to ask question if you don't understand something. So we make help pointer and we make it point to my list. Now we have a while loop. While, because you asked me about a for loop, we have a while loop. While help pointer does not equal to null, we need to do our traversal. Print, traverse, print, traverse. But let's look at this while loop. It's simply making sure that we're pointing to some valid node. Okay? Because maybe the list is empty. مثلا, the list is empty. I'm a help pointer. I get the value from my list. My list is null and a null. Come on. So I say while help pointer is not equal to null and a null. خلاص, I don't do anything. لا ندخل loop and we exit. Are you with me? But right now we have a list. Our list, I'm pointing to Khalid. So while help pointer, and help pointer, while help pointer does not equal to null, am I null? No. أدخل loop. Who's with me? Our list is, help pointer is not null, I enter the loop. What do? I print Khalid, help pointer.data, I print the data values, whatever I want, first name, last name, whatever data, I print it. بعدين, what is step 2? Help pointer equals help pointer dot next. So here, I enter, I print it. What is step 2? Help pointer equals help pointer dot next. Do I need to give you a big sharh for this line? We just did it for 10 minutes. Help pointer equals help pointer dot next. What does it do? It moves us one line down the list. So let me try this. I'm help pointer. Yeah, my list. Find a list. Shukran. I'm pointing to Khalid. Is help pointer null? Is help pointer null? No. I enter the loop. I print the data. I print Khalid. بعدين, what is this? Step over. Okay? Now, is help pointer null? No. I print Baha, step over to Ghassan. Is help pointer, I'm pointing to Ghassan, is help pointer null? No. I print Ghassan. Point to the ceiling, please. Higher. Everybody can see you. Okay. So now I need to do this node. I need to do this line. Help pointer equals help pointer dot next. Point higher, please. Help pointer, I'm pointing to Ghassan, equals help pointer dot next. So I take the address of his next, which is what? What is the address here? Null. And I save it into help pointer. So we print Ghassan, I step over, but now where am I pointing? To null, nothing. The ceiling is nothing for us. I'm pointing to the ceiling. So now when we do this line, while help pointer is not equal to null, I'm null. We exit the loop. Who's with me? So if you understand, then you can just follow and study it on your own. That was our example. Now we have an example in more detail on the slides. So we print the data and we traverse down one step. We do it again, we print the next node, traverse down. Print the next node, traverse down. So on and so forth. At some point, we come to the last node. And the next of the last node, Ghassan, the next of Ghassan will point to null. Okay? And that null value will get saved into help pointer. Yes? And this will make us exit the loop. Clear? This code right here is the core, the asas code for anything traversing, printing, searching, deleting. You need to understand this mi'atain with me. Perfectly. Eyes closed, you should see it. Understand it perfectly. And if you can, then inshallah deletion will be easy, insertion will be easy, all of it can be easy inshallah. But this is the first step. So my question, I say, would the following code be valid? Shabab, look at this code. Would this code be valid? Would it work? It would work, but we need 3 manadil. One for Khalid, one for Baha, one for Ghassan. Why? Because we lose the list. This will work. So it's not a trick question. Does it work? Yes. Is it smart? No. You lose your list. Okay? Clear? Who's with me? This is the same code, but we use no help pointer. We do not use the help pointer. Then we will lose our list. Okay? It would be valid, it would traverse just fine, but we would lose the list. Okay? Our list would be lost. So remember, whenever you traverse list, you always need a help pointer. You should never ever use the head of the list. Even if you don't need the list anymore, you should never use the head of the list. Okay? It should be good programming practice to always use the help pointer. So now that what did we just do? I wanted to print a list. So I printed the list. I print, traverse, print, traverse, print, traverse, done. What if I want to modify the entire list? I want to take his data value of Khalid, I want to multiply it times 10. Ba'dain, I want to multiply the data value of Baha times 10. Ba'dain, I want to multiply the data value of Ghassan by 10. Who's with me? Is this code different? Not really. Same code. Instead of print, I modify. Okay? So here's the code, same thing. What's the difference of this code? I say, instead of print, the method, instead of print all nodes, the method name, modify all nodes. What's the first line? Help pointer, LO node help pointer equals my list. We make a help pointer, it points to the nafs al-unwan as my list, so we point to Khalid. We have the same while loop, biddabt. The same second statement is traverse the list, biddabt. The only thing different is the first statement. Instead of print, what do? Help pointer.data equals help pointer.data plus 10. So this, maybe your data is 4. It says, make it 14. Your data is 8. Make it 18. Your data is 27. Make it 37. Your null, fifth. Who follows? So all of the traversals are the same. Maybe you're modifying, maybe you're printing, maybe you're doing this, doing that. It's all the same. The same basic heikel, skeleton of a traversal. Okay? I'm not going to go, we just went through it. I think you can get that. There's many operations that we do on a linked list. Insertion, deletion, searching for nodes, and for all of these operations, you need to know miatain bil mia. You need to know traversal. Okay? Next time we go over insertion. Was it amazing? No, we're not completely done. Hit stop. Yes. Okay?